outside the circle. Okay, so what we want to start to kind of explore today are angle relationships in circles. And this section, I think, is probably going to get a little more difficult than what you've seen. But I think if you follow the rules, life will be pretty good for you today. Okay, so that said, let's get started on 10.5. We have a title up there, 10.5, called Angle Relationships in Circles. Okay. How about a volunteer to read my essential question?
When a chord intersects a tangent line or another chord, what relationships exist among the angles and arcs formed?
Okay, so we're going to have some intersecting chords, and this term comes up again, tangent line. So we're talking about intersecting chords or intersecting a chord with a tangent line. Looking at the relationships among the angles and the arcs that are formed. So our goals today are to find angle and arc measures again. That's going to be a focal point. And then we're going to use, what's the word? Circumscribed angles. Okay, we'll talk about circumscribed angles today. We better figure out what that is. Okay. First term is circumscribed angle. A circumscribed angle is an angle whose sides are tangent to a circle. So if you look at this example right here, guys, basically, remember a line of tangency? Yeah. A line of tangency is a line that goes and touches the circle at how many points? 1 point. So this angle right here is called a circumscribed angle because both ray BA and ray BC are what kind of rays to this? Tangent. Okay, so we'll talk about that right there. But that's a circumscribed angle. Good visual there. Okay. Guys, aren't you really happy? I kind of even started saying, instead of us drawing them, there you go. Yeah. All right. You guys remember what a line of tangency is, right? Yep. It's a line in a plane of a circle that intersects the circle at exactly, what's the word? It's like this circle right here. What's my point of tangency down there? What point does the circle intersect that line at? B is the only one. Okay, it's kind of like where the tire meets the road, if you will. Okay? All right, a chord, you should know what that is. That should be prior knowledge. It's a segment whose endpoints are on a circle. A chord, like ST can be here, but if you have a chord that passes through the center, what's another name for QR here, guys? Diameter, okay? And then recall secant. A secant is a line that does what? What's the difference between a secant and a chord?
It goes through the whole circle.
It goes through and keeps on going. The chord is going to have endpoints on the circle, okay? So really, the only thing that's new for us today, guys, is what? Yeah, circumscribed angle. Understand that, okay? All righty then. Are we good on vocab, kids?
Yes, sir.
All right, let's move on this today. Let's start with the first thing that we need to understand, and there's a theorem up there. Okay, this theorem is called the what? Tangent and intersected chord theorem. How about a volunteer to read that theorem for me, please?
If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intersected arc.
Okay, now this doesn't show up very well right here, but here's the deal. They have, first of all, what's your line of tangency here first? Is that what's the point of tangency down here? Does that say A right there?
Yeah.
Okay, so it doesn't show up well when I blow this up, but you have it on your notes right there. A is down there. Okay, you guys see this red arc right here? Okay, the chord BA intercepts this tangent line right here. It says the measure of angle 1, kids. See measure of angle 1, this angle right here? That measure is half of what? All right, so if AB was maybe, I don't know, 100 degrees, what would the measure of angle 1 be here? 50, okay? And then the measure of angle 2 is going to be half of which arc? The blue one there, okay? So if you ever have a chord and a tangent intercept a circle, the angles are going to be half of the what?
The arc.
Arc, and we've kind of talked about stuff like that in the past, haven't we? Okay, again, that's kind of similar to what we dealt. So let's use this example right here, okay? It says line M. Line M is a tangent to the circle. Find the measure of the what, kids? Red angle or arc. Well, guys, what's the measure of this arc AB going around here? We have this chord AB intercepting this tangent line right here. Angle 1 is formed right down here. How is that angle related to that 240 degree arc? It's half of it. So the measure of angle 1 should be what? How many degrees? I'm sorry, I didn't catch that. 120. Are we all in acceptance of that? Perfect. So if you see a line of tangency in a chord, understand that these angles are half of the arcs. Okay, check this out. Right here we have an angle that's formed from line M. It kind of goes from this line of tangency in a chord. This angle that's formed right here is 155 degrees. So the arc I'm looking for here, guys, in red, we're really looking for the measure of, how would you name this arc in red, kids?
LJK.
Can I just say LK?
LJK.
I got to call it LJK because remember, when we have just two letters, that assumes which arc, major or minor. So in order to get this, do you guys agree that L to K in red is really a major arc? So to make sure we're going at, we're really looking for the measure of LJ. Okay. Well, what's that angle measure down there, kids?
155.
Then we have a chord, and that chord meets at a line of tangency at 155 degrees. So what are you going to do to that angle to get the measure of that red arc, LJK? What is 155 times 2? Okay. So if you see a chord intercepting a line of tangency and you see the angle relationship as it relates to the chords, you just need to understand the angles are half the chord, or the chord is, the arc is twice the angle measure there. Okay? Okay with that example right there, kids? All right, so theorem time. Here we go, theorem time. Ooh, boy. Let's talk. Yeah, I agree. Okay, let's start with the left side right here first, okay? So if you look at the diagram right here, again, these don't show up the best up here on a projector, but in your notes they show up pretty well.
You sure about that?
Okay then, never mind. All right, angles inside the circle theorem. Says if two chords intersect where, kids?
Inside.
Inside a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the what? And it's, okay. So what this is simply saying, kids, is this. It says, go to angle 1 down here. If you read that on your notes, it says the measure of angle 1 is equal to, see where angle 1 is here, kids?
Yes.
All right. That's equal to 1/2 the measure of which arc in red, kids? DC. Is that a plus sign?
Yeah.
Plus
AB.
the measure of arc AB. All right. Then the measure of angle 2. You see measure of angle 2 right here? What is angle 2?
1/2 of AD.
AD. So again, it's half of AD plus what?
BC.
Okay, the one that's across from it. So we'll look at an example here in a second. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum.
Carson,
Yes.
may I have Elijah mark this, please?
Yep. What'd you guys do? What's going on?
The thing is, when Jonathan watches this, it's not his lunch money, and he's
Okay.
not back there.
It's not.
Okay.
They don't take people out of class right now. They just do that.
Yeah, I know, because Barbara didn't come
So
up
guys,
back there.
do you see where angle 1 is at?
Yes.
You're always looking at the arc that one intercepts and the one that's opposite of it. You're going to add those two together and then cut that measure in what? Okay, same thing with angle 2. You're looking at the arcs that it intercepts, in this case BC, and the one that's opposite of it, which would be what? AD. You're going to add them together and then cut it in what? Half. Okay, I think there's an example I want you to try with that right here. Let's skip ahead. Remember, this only works for angles where chords intersect where? Inside the circle. So what I'm getting at is this. In example number, yes, 2. Example number 2, we have to do what, kids? Got to find the value of x, don't we? Okay. Well, kids, right here, do you agree that 80 degrees is an arc that we know right here? And x is another one we're going to have to know. Would you agree with that? Okay, and you also agree that these are two chords that intersect inside of a circle. Okay, so here's how this works. I know that this is 94 degrees right here. Any way to figure out this angle right there? Well, you have a straight line here, don't you? So wouldn't this angle and this angle be supplementary? So what's 180 minus 94? 86 degrees. So you agree that this is 86 degrees. All agree with that? Okay. So here's the deal. Remember, the angle has to equal 1/2 the sum of, I'm going to write it this way, half the sum of your intersecting arc plus the opposite arc. Okay? Your angle measure equals 1/2 the intercepted arc plus the opposite arc. Guys, do we know the angle measure right here that we're working with? What is it? 86 degrees is going to be my angle. That's going to equal 1/2 of, okay, this 86 degrees, which arc does that intercept? 80-degree arc. How about your opposite arc? Do we know that? Opposite of the arc, 86x. Okay. Is there enough information up in there to solve for that arc measure now?
Yeah.
Okay, help me. Let's multiply both sides by what first? Well, how do you undo? Well, times it by 2. So if I time everything by 2 here, I've got 172 on the left. That would equal 80 plus what? Right? I gotta solve for x now, kids. Minus 80, what do you get? 90. Okay. Okay, can I give you kind of maybe a shortcut to that? Okay. What was the angle that we were going to use to... Okay, we knew that that arc up there was 80 degrees, right? So we needed that 80-degree arc to subtend back to an angle. So this 80-degree arc right here subtended back to which angle, kids? 86 degrees. Think of it this way. To go from an 80-degree arc to 86 degrees, how much did that change? What's the change going from 80 back to 86? Which means if I would continue the pattern, if I keep going up by 6, this has to be the average of this, and this is basically what that's saying. So if 80 is 6 below my angle, then this should be 6 above the angle, which would make it what? Whoa.
Can you do that with everyone then?
You probably could, but you would have to have an arc somewhere else. We don't know these arcs right here, so, but yes, you could. You could. All right? What this is really saying, kids, is this. This arc and this arc right here, are these arcs opposite of each other? The average of the arcs is that angle. Make sense? Okay. Gnarly. Now, guys, are chords only going to intersect inside a circle? All right, let's see what else can happen here. Let's go back to that other theorem. You guys agree that this is going to be a little more complicated than the things we've been doing? Okay. Instead of having angles inside the circle all the time, we can also have angles where? Outside the circle. And it says if a tangent and a secant, two tangents or two secants intersect outside of a what?
Circle.
Okay, so they're talking about points of intersection being here, here, or here. Then the measure of the angle formed is 1/2 the, what's the word this time? Difference of the measures of the intercepted arcs. In other words, this is saying if your angle falls outside, you take big arc minus little arc and cut it in half, and that's your angle. So if it's outside, let's write that. Really, for an outside angle, your angle is going to equal 1/2 the big arc minus the what? Okay. So they talk about it right here. What's the big arc right here in example 1? Big arc's in red, isn't it? BC minus what? And that's this right here. Cut it in what? Big arc, PQR minus little arc, PR. Cut it in half. Red arc minus blue arc. Whatever that is, cut it in half. So let's move ahead on the next example and see what the heck we've got. Okay, guys, what do we have to solve for? X, okay? Let's see, is this an angle inside or is this an angle outside? Okay, so if this is an angle that we're talking about outside, by the way, are these two tangents, a tangent and a secant, or two secants? Two secants cutting through, okay? We just got done saying the angle measure is going to equal 1/2 the big arc minus the what? Okay, let's fill stuff in appropriately, see what we can come up with. Kiddos, do we know the angle measure? How much? How many degrees? 35 degrees is going to equal what? Do we know the big arc? 100, right? Boom! Minus the little arc. Yeah, minus x. Oakley dokley, kids. We need to solve for x. I want to get rid of that 1/2 out in front, so what am I going to do to everything?
Multiply the other side by 2.
So 35 is going to turn into what?
70. And then you're going to subtract the 100.
Equals 100 minus x, right? Okay, you want to subtract it, or maybe you guys can say, oh, I know what x is going to equal to make that true. But if I wasn't sure, I'd subtract 100. This would be negative 30 equals negative 1x, which means x would equal how many degrees?
30.
Hey, quick question. Check your work. Again, where's the angle at? Inside or outside?
Outside.
Outside is half the difference. Inside is half the sum of the arcs, basically. If you can just remember that today. If you have angles formed inside, angles inside are half the sum of opposite arcs. Outside angles are half the, not sum, but difference. Okay, check this out, kids. What do we think x is equal to? 30 degrees? Hey, quick question. What's 100 minus 30, minions? 70 cut in half is? Okay. Understand how the angle formed outside a circle works. Okay. Let's go back and summarize those theorems. We kind of did this one right here. Where am I at? This page? Okay, we kind of summarized this one, didn't we? Half of the big minus the little. And I should put big A minus little a, where A stands for what? Not angle, but I should put big arc minus what? Little arc. Okay. Papa Noah's arc, baby Noah arc. Okay, never mind. That wasn't funny. Even though it is going to rain today.
It is?
Yeah.
Yeah. Is it supposed to
Like this afternoon, yeah. And evening.
Into like 5. It's only to like
Before, after
2.
5 o'clock.
Around 4.
More like 2 to 9. 2 to 9.
No. It's only 2 to 4.
That's only
It
2 to
changed.
4.
And there's like a 40-76% chance. So, might not rain at all.
Maybe at 3 o'clock.
There's so,
47. Yeah, maybe at 7.
Guys, I'm going to summarize the inside the theorem, or inside the circle theorem, by calling it my angle is equal 1/2 the intercepted arc plus the what?
Opposite arc.
Opposite arc. Okay, you might want to summarize those theorems with what we have right up there. Are we good?
no.
I'll wait.
Something big must be going on. Big slack just probably caught everyone with a jewel.
No, I think I read an email that said that there's some people from UNI that have to There's students that are doing counseling questions. I think they're choosing students at random for them to interview, actually. Okay, so are you guys okay with example number 2? Finding an angle measure or an arc measure, but typically an angle measure. Okay. Another theorem, kids. It says this. Ooh, what kind of angle do we have here? If you look at this example, circumscribed angle occurs when you have two rays that run. They go and touch just one point of the circle. What's it say? Tangent to that. Okay, so what this says, kids, is the following. It says the measure of a, why is this circumscribed again, kids?
Because it's okay, so it's like the two tangent lines that come together.
Yeah, two tangents.
So the angle is tangent, not just one spot, but actually in both places. Both sides of the angle are tangents to the circle. That's what it means to have a circumscribed angle, okay? So it says the measure of a circumscribed angle, we understand what a circumscribed angle is, equal to what? 180 minus the measure of the central angle that intercepts the same arc. So they're saying the measure of angle ADB, the measure of this angle right down here, is equal to 180 minus what? Let's think about this. For a circumscribed angle, this angle is going to equal 180 minus the ACB is what kind of angle if that angle is in the center of the circle? Okay, it's 180 minus the central angle. This only happens when both sides are... This only happens when both sides of the angle are tangent to the circle, or in other words, a circumscribed angle. So let's take a look at this, kids. Down here it says find the value of what, kids? X. Well, kids, what do you notice about angle QSP? What kind of angle is this? It's circumscribed because both sides only intercepted a point. So we know that by this little rule right here, my angle has to equal 180 minus the, I'm going to write it as CA, which stands for what? Central angle. Okay, well, we're trying to find the angle, which they define as what, kids? X degrees will equal 180 minus what?
56.
Okay, let me kind of tell you why this is true. You guys remember what angles formed at a tangent line down here?
90.
If I would cut this in half like this makes two equal triangles. Think of it this way. What's half of 124, kids? 60 what? If I could figure this angle out down here now, right?
And then you can double it.
And then I could double it.
Ah!
Okay, so let me just tell you right here, when you do this, this turns into be 28 degrees. And then if you double 28, it becomes what?
56.
All right, so backing up on this, let's see if that holds true. We would know that's 56 degrees if I drew that line in there. What is 180 minus 124?
50. Oh, wait. Yeah. 56.
100 and?
Wait, I'll repeat it. What was the question?
Come on, guys. X equals 56.
Yeah. Yeah.
How much?
56.
All right, very good. Isn't that what we thought we would get?
I knew.
I'm just messing with you, Grace, getting you fired up. Is it working? Huh? Late.
Can you do x plus the other angle equals 180?
Yeah, you could do that. That works so I know for what type of an angle. Okay. Now, guys, I'm really concerned about this next one.
Wow. Are you really?
Mm-hmm. I really am, brah. What?
No.
Don't do that?
No.
Sorry.
Yeah.
No, you can do it.
Was that so 2018?
So like, wait, what year was it when we were in third grade?
Okay, never mind. Stop it. You make me feel old.
It was.
And
I think it
I'm going to open the book on this one here. You guys, I'm concerned about this next one right here. Example 3, letter B. All of a sudden, your angle isn't where?
inside the circle.
But it says something. Do we have a circumscribed angle again now?
Uh-huh.
Okay. So let's just consider this. Let's just consider this. I guess my question is, how in the world am I even going to find x?
Did you send it?
Okay, I have an idea. You want to hear it?
Yeah.
Okay.
Headshot idea.
This problem is pretty tricky right here. But, kids, the angle I'm looking for, is this angle on the circle, inside the circle, or outside the circle?
Inside.
Actually, it's right on there, okay? And from last section, here's the deal. If I can find maybe this arc from here to here, kids, see what I'm talking about? Arc AB here. If I can find arc AB here, then wouldn't that arc AB be twice the angle x here from last section? All agree with that? Okay, check this out. What you need to do in a problem like this, is start right here. Let's make a central angle in here. Why didn't that work? Make your central angle like so. Are you there with me? Consider from A to D and then from D to B and then that shape. Isn't everything that's from A to D and D to B and then in red right here just like what I have over here? Okay, now guys, we know that when you have central angles, if this is like 100 degrees, then the arc would be what? It would be 100 if it's central. Okay, it's only half of it when you have intercepted arc. So check this out. First of all, do you have a circumscribed angle in example B?
Yes.
Okay, both sides are tangent, right? So since I have a circumscribed angle, then this should hold up. The angle measure outside the circle should equal 180 minus the what? Okay, so let's just work with that right here. I would be able to say my angle would equal 180 minus the central angle. Okay. Well, do we know the angle measure we're working with outside? Do we
Mr.
know?
Larson,
Yeah.
send Leighton Smooth to the office, please.
Yeah, but the third time you're getting billed this time.
Still Miss Chris.
All right, I will.
Messenger.
All right, hey, hey, you know I'm only messing with you, right?
I know.
I know.
If you brought us pies more often, we would call people out of your room less often.
Well, I'll throw that message.
It's a tippy scale, you know.
I'll throw that message Mindy's way. How's that sound?
Perfect.
All right.
Thanks.
Love you guys.
Bye.
Okay. Would we be able to solve for the central? Can I just call the central angle? Let me back up here. Is it okay? We already have x up here, so is it okay if I call this angle measure y degrees right there? Are you guys okay with that?
Yes, right.
Yeah.
Okay, so this would be like 180 minus y. Help me out, kids.
Well, what do we call it?
Y equals 138.
How much?
138.
138 degrees. So y is 138 degrees. So that means the central angle is how many degrees, kids?
138.
138. Since that's a central angle, kids, what's that mean about this arc measure right through here? Central angle, so it's got to be 138. So what's your rule about inscribed angles then? Won't angle x be half of that arc now? It will be, won't it? Okay, so just like last section, what we really have here is an arc of 138 degrees. This inscribed angle, it subtends back to angle x of an inscribed angle, so x would be half of 38, which is, I'm sorry, 138, which is
64. Wait, 74. 60. Oh.
Well, that was kind of tough, wasn't it? The trick to using that one is this, kids. Did they give you a central angle in that problem? No. And we had to come up with a central angle because we were working with what type of angle outside of my circle. What's the name of that angle outside of the circle when both sides are tangent to my circle? We're dealing with a circumscribed angle. So the only thing I can say is, okay, well, this angle y is a central angle. We found that 138 degrees. Since that's the central angle, that's the same measure as my arc. But if I would subtend this arc back to the inscribed angle of x degrees, we know that relates to be half of that arc, 69 degrees. That's some pretty upper level stuff that we're dealing with here, kids. Okay. Questions so far? All right, last example. The northern lights are brief flashes of colored light between 50 and 200 miles above the earth. Have any of you guys observed those ever before? Have you, Lincoln? Pretty cool. I've never seen them before. All right. It says a flash occurs how many miles above the earth?
200.
At a point what?
C.
Okay, which is right here. All right. This is what is the measure of length what, kids? What is the measure of BD? Oh, it's not an arc. No, hang on a second. I want to read that.
We have advisory.
Okay, this here, guys, I thought that
Sharing myself because I was like, oh,
right here, I wasn't able to get that typed in there. This should be the measure of arc BD right here. So we're looking for the measure of this arc right here. How many degrees is that? The portion of the earth from which the flash is visible. Okay? So, all right. It says the radius is approximately how many miles, kids?
4,000.
Okay, if this is 4,000 miles, the radius was 4,000 miles, wouldn't the radius then be, a radius would be from A to B, wouldn't it, kids? Our job is to find the arc from where to where? B to D. Okay, so I'm going to call this 4,000 miles. Whoa, that didn't work out very well. Hang on a second. What color should I use on it? Yellow, okay?
Sure.
This is 4,000 miles, okay? Now we're going to assume CD runs, what here, kids? Tangent to that, so what angle is going to get formed right here? 90, okay? You know what this distance is how much right here, kids? That's the hypotenuse, right? Okay, our job is to find the measure of this arc. How many degrees is this arc up here? How many degrees is that arc right up here, which would match really this central angle down here, wouldn't it, kids? You guys agree with that? Okay, so guys, we need to figure out an angle down here. We've got to go back to some things that we remember about triangles. Specifically, what type of triangle is formed here again, kids? Okay, guys, here's the deal. In something like this, if I could figure out the measure of this angle right down here, I should pick a different color for that. If I can find the measure of this angle right down here on a triangle on the right side, how is this going to relate to this over here then? Wouldn't these angles be the same? And if they're the same, wouldn't that tell me what the measure of arc BD is then if I can figure out that angle down here, central? Okay, so we're going to do that. So here's how this is going to work, kids. I'm going to make a drawing here as best I can. I'm going to kind of draw a cross section right over here of what's going on. I'm going to draw a triangle ADC. This is kind of what I see right here. This is a right angle. This is like the point C up here. This is like D. And this is like my point A down here. We're trying to find this angle measurement right there, okay? What's this distance right here again from A to D? That's my radius. What's this distance right here? We can use those to find the measure of an angle. Here's how it works. First of all, relative to angle A down here is 4,000 the leg or hypotenuse. Specifically, what kind of leg? Adjacent or opposite? It's adjacent. What is 4,150 in this triangle? What function uses adjacent leg and hypotenuse?
Cosine.
So what I'm going to do here, kids, is this. I'm going to say over here, the cosine of this angle that we're working with, the cross section, cosine of angle A equals, what is the adjacent leg length, kids? Over what? Somebody run this 4,000 divided by 4,150, and let's run that to 4 places, okay? You guys remember how to work backwards and find a measure of an angle when the ratio of that cosine is 0.9639. Remember how to find angle A? Yeah, it's like a well, close. We have to do the inverse of that. Very good. We would say angle A is equal to the cosine inverse. Remember, cosine inverse in your calculators is like cosine to which power? Of what value? What do you guys get when you punch that in? Nearest 10. So A is equal to about 15.4 degrees, is that right? But kids, I have a question. How many A's do we really have to find to get this arc measure up here? 2. So we're going to take 15.4 times 2. We think arc BD then is 2 times 15.4, which is, I'm sorry, how much, Sonny? 30.8 degrees. That's bad. Come on, Parson. 30.8 degrees. Guys, I'm going to ask you to do the peer evaluation, see what you come up with on some of this. I'd like to have this done by the time we start class tomorrow. I'm going to send out the new online to you right now. What questions do you have for me? A little more complicated today, isn't it? Okay, so we're going to spend some time working at this tomorrow. Got plenty of time tomorrow, but I would strongly encourage you to get into the online